All right. So it's past 3 minutes. So let me just share my screen and let me know if you guys can see the presentation.
Yes, we can see the presentation, Donna.
All right, so I guess we can now start. So, hello again, everyone. Thank you for joining our webinar titled Pesticide Use from Pest Control Effectiveness to Food Safety and Sustainability, presented by Agronomica and Fitosoil. I'm Dana Sanchez, your host for today's session. So, if you have any questions in the middle of our presentation, feel free to use either the chat box or the Q&A section, and we will address those questions towards the end of our program. So before we dive into our main agenda, let's introduce our speakers for today. So first, we have Patricia Tello, an agronomist engineer and the founder of Agronomica, bringing over 18 years of experience as the head of the laboratory. So next up is Dr. Caroline Gutierrez, a professor at the Faculty of Agronomy at the Federal University of Rio Grande do Sul and a consultant at Agronomica. Our third speaker is Francisco Ferrer, a managing director of Fitosoil since June 2023, having joined Fitosoil in December 2021 as director of operations to support the transition period of Fitosoil's entry in Cotecna. So prior to joining Acotecna, Francisco had worked for 15 years in other food safety laboratories, most recently as production manager. So Francisco holds a degree in chemical engineering from the University of Almeria. And then lastly, we have Marco Antonio Caro, our pesticides manager at Fitosoil with a PhD in chemistry. Marco brings over 2 decades of experience with the last a decade dedicated to Fitosoil. So now a brief introduction to our company, Cotecna. So we are a leading provider of testing, inspection, and certification services dedicated to making supply chains safer and more efficient. So we are headquartered in Geneva, Switzerland, with offices and labs worldwide. We have over 7,000 employees serving in 140 plus locations. So our expertise spans across agriculture, food safety, metals and minerals, and consumer goods and retail sectors. So as we celebrate our 50th year anniversary, follow us on social media for insights in our journey and key milestones in the testing, inspection, and certification industry. So to discuss our main topic for today, I'll now hand it over to Patricia.
So, hello, good morning, and good afternoon for everyone. First of all, to start our webinar, I'd like to present a little about the services we can offer here at Agronomic. The first slide, please, Dana. Founded in 2006 in Porto Alegre, south of Brazil, Agronomica is a phytosanitary consultant and diagnostic laboratory that operates throughout the country. In these 18 years of servicing, Agronomica, in partnership with the Ministry of Agriculture, has helped detect and determine quarantine pests for Brazil, as well as phytosanitary restrictions for partner countries. Over the 18 years of collaboration with Ministry of Agriculture, Agronomica has improved its teams of professionals and worked to offer specialists in different classes of pests. Today, we have 7 specialized laboratories for phytosanitary diagnostics, as well as laboratories that provide support services for our activities. This means that throughout the history, plant health diagnosis has been Agronomica's main service, and our mission become to promote plant health and combat the traits to contribute to food security and sustainability. Next slide, please. Over the years, we have diversified our services to offer different tools that can help the production chain in its different stages to make decisions. We realized the importance of offering services for analyzing the quality parameters of certain bioinputs to certify products used for pest control, which are then known as biological control products. The chemical and biological product sector has started to demand of us certified reference materials for carrying out laboratory tests and evaluating products in the field. This demand provided us the opportunity to create our collection of pests and microorganisms, which we call SVG. Structuring a collection of certified reference materials was a natural process for us, as we are able to greatly diversify our collection based on interceptions of pests in samples from different countries around the world, and with the authorization of the importers. Today, we have a benchmark provider in Brazil. We are a benchmark provider in Brazil. About 3 years ago, we realized the need to offer the agronomic efficacy of chemical and biological products service to different companies in the agriculture sector as a complementary activity to what we already offered. In this way, Agronomica is a company that meets the demands of disease diagnosis and pest detection and identification in different agriculture products at different stages of the chain. We offer diagnostics from the field to international commodity transit process. Agronomica offers collections of pests and microorganisms both for research and to carry out studies. And we offer the possibility of analyze the quality parameters of products used for biological control, as well testing the efficacy of chemical and biological products for this usage. Next one, please. So we offer efficacy tests for chemical and biological products, as well compatibility analysis between them in the field, in greenhouse, and in the laboratory with controlled tests. As an example, to understand the meaning of efficacy test, in 2023, we carried out a trial to evaluate the effect of fungicides in the treatment of soybean seeds to control fungi under controlled conditions. Next one. In 2023, we had a total of 39 trials. Comparing the number of trials between 2022 and 2023, we see an increase in the number of trials from 100% in greenhouse, 56% in the laboratory, and 11% in the field. We can say that 54% of efficacy trials are carried out in the field, 36% in the laboratory, and 10% in greenhouse. Concerning the number of trials per pest class, we can see that the trials to evaluate products for fungal control in the field is predominant for us here at Agronomic. Now I pass to the next speaker, Caroline.
Hello everyone, it's a pleasure to be here in this webinar, and today I'm going to talk about the importance of the agronomic efficiency tests that are made prior to the use of a pesticide by the producers. Next, please. So, what's the role of Brazil? With the increase in world population, there is a need to increase food production, but in a sustainable way. And we have to increase about 69% in food calories to feed all people that we are going to have in 2060. And Brazil has a fundamental role for global food security because we are one of the main producers of food and exporter of food. And here we can see some examples like orange juice, coffee, soy, sugar, corn, chicken, and pork. Next, please. In addition, Brazil has one of the largest agricultural areas for expansion, with no need to use environmental preservation areas. And it's very important. As we can see on the map, we are among the countries that have the largest forest area in the world. And we want to continue preserving these areas. Increasing production capacity in areas that are already agriculture is an important point. So we can expand areas, but we need to improve production in areas that we are already producing. And for this, research and technology are very important. Next, please. And what does pest control effectiveness means? It means that the efficiency of a given molecule is evaluated in relation to its target, like a fungus, a bacteria, a nematode, or a virus. There are hundreds of chemical and biological products focused on disease and pest control for use in agriculture. And it's worth to noting that preview these tests of effectiveness, a lot of tests of safety and toxicity are needed to see if there is no problem with environmental, humans, and animals. The efficiency of a given molecule is a fundamental condition for agricultural pesticides to be used by farmers. Furthermore, these tests are necessary here in Brazil for products to be registered by the Ministry of Agriculture. To summarize, pest control effectiveness studies helps farmers choose the most effective products for management with less environmental impact, and that brings greater profitability. Next. And how does this kind of tests helps sustainability? Testing the effectiveness of products ensure that only products proven to be effective for their intent purpose are used by producers. And this kind of tests helps to determine the best pesticides, avoiding unnecessary or inappropriate use of molecules that do not work, resulting in more assertiveness and lower production costs. For this reason, knowing how to use the right product at the right moment and in the right dose helps to avoid unnecessary applications that could increase production costs and harm the environment. Next. And what's the role of Agronomica? Like Patricia said, we carry out studies in laboratory, greenhouse, and field conditions that can contribute to validating the efficiency of these products that are used in control of disease or agricultural pests in different crops, especially soybean, corn, and wheat, but we can test other cultures too. And what can we evaluate? Next, please. So here we are gonna show some examples. And the first one, it's a kind of test conducted in the laboratory where we can see the sensitivity to a chemical or a biological product in plates. Here we bring the example of olive production because Rio Grande do Sul state, the state that Agronomica is located, here in Brazil, in the southern Brazil, is responsible for about 70% of the production of olive in Brazil. But we have an important disease caused by a fungus called Coletotricum nymphae that causes anthracnose. And here in the pictures, we can see three different treatments. In this first picture, we can see the control treatment, where we have no fungicide or no chemical used in the plate, just the fungus. So the fungus can grow through all the plate. And we have number 1 and 2 treatments, where we can see that treatment number 1 is more effective than treatment number 2 in controlling this fungus, because we can see that the colony growth in the number 1 treatment is smaller than in treatment 2. Next, please. Here we have another example of a test conducted at the greenhouse where we evaluated the soybean nematode. It's another important pathogen from soybean and corn. And this nematode is a kind of microscopic worm that affects the roots of these cultures, causing symptoms like galls, as we can see in this picture. And here we evaluated two different treatments. We have a treatment that is uninoculated, where we can see that there is no galls and no population of the nematode. We have an inoculated control, where we can see that we have a lot of galls and a big number of individuals of nematodes. With the use of chemical control, we can see that we reduce this number of galls and the final population of the pathogen. But we can see the synergy here with the use of chemical and the biological control. As we can see that we have the greatest or the smallest number of galls and a lower population in the final treatment. Next, please. Another example is in the field, where we can access incidence and disease severity, as well as yield and other evaluations. Here we have some pictures about soy cultivation. And in the picture below, we can see an important disease of soybean. For sure, the main disease on soybean, called soybean rust, caused by Phacops pachyrhizae, a fungus. And we can see in the image in the right that we have a great difference between a treatment that we don't have a chemical pesticide, like a fungicide, and a treatment with fungicide. And for soybean, it's very important because for this kind of pathogen, soybean rust, we don't have resistance. So the use of a pesticide, in this case a fungicide, is very important. Next, please. And the final example here, we have two important wheat disease, leaf spot and Fusarium head blight. And we were comparing three different treatments, a chemical fungicide, just a biological fungicide with Bacillus pumilus, and the combination, the synergy with chemical and biological fungicide. And we measured the yield in bags per hectare, and the disease control. And as we can see, with the combination of chemical and biological control, we improve the yield and the disease control. So it's a great tendency, and the use of biologicals are growing in all the world, and especially in Brazil. And it shows that the combination of chemical and biological products are very effective, and it's a kind of management that goes through sustainability and helps the sustainability in agribusiness. Next. In our field, we also promote a kind of field days where we invite the main clients to see our own researchers, that kind of experiments that are not contracted by the companies. And it helps to disseminate knowledge to our main clients. Here we can see a picture about our last field day. And we can generate material for scientific publications, and as well material for marketing and social media from Agronomica. In the picture below, we can see the mosaic of colors, and they correspond to different treatments applied in soybean, chemical and biological treatments, and we can see great difference between them. So some are more effective than others. Next. As we can see, the path between the development of products to control pests and disease and until they are used by producers is a long way, but it's a very important path. Pest control effectiveness tests provide security for users and guarantees the effectiveness of these products used in the field. Agronomica is part of this production chain, contributing to sustainable management and food security through the use of duly tested products with proven effectiveness. Now, Mr. Marco is going to talk with you. Thank you.
Thank you, Caroline. Good afternoon from Spain. Good morning, everyone. It's a pleasure to join this webinar. I'm Marco Antonio Caro, the head of the Pesticide Department at Fitosoil. In this webinar, we are going to deal with two topics in the use of plant protection products. First, soil contaminated by persistent pesticides and stability study of commercial plant products. Phytosoil analyzes the physical chemical characteristics of soils, including the scale established for agronomic purpose, regardless of the type of crop and the technical method used for its exploitation. Pesticides contained in soil from previous crops are also analyzed, including organochlorine pesticides considered persistent because have semi-degradation period of more than 1 year. All this information is useful for our clients to select the right crop and correct nutritional deficiencies or excesses that might be present. Furthermore, the presence of persistent pesticides in soils limits the use of soil for organic crops. For example, in the region of Murcia, Spain, organic crops account for 32% of the cultivated area, exceeding the European Union minimum required of 25% by 2030. Next, please. During the second half of the 20th century, organochlorine insecticides such as aldrin, endrin, heptachlor, or DDT have been widely used in agriculture to eradicate insect-borne diseases such as malaria. These pesticides accumulate in fatty tissues. In humans, affect the nervous system and are considered carcinogenic. In Spain, it has been used on all types of crops and especially on rice, causing contamination of sulfides and groundwater and malformation in birds. DDT was banned in the USA in 1972, while in Spain its use was extended until 1994. Next, please. At Fitosoil, we analyze DDT and its main metabolites DDE and DDD, all with high toxicity and half-life between 5 and 15 years, depending on environmental conditions. Therefore, with effect that will continue into the 21st century. This insecticide is not water-soluble and accumulates mainly in agricultural soil with silt and clay fractions about 25%, which are less permeable. Soil organic matter also facilitates the absorption of organochlorine pesticides. Therefore, soil characterization is very important to know the accumulation of organochlorine pesticide in the different soil fractions. Next, please. In Fitosoil, we have analyzed in the last years more than 2,000 soil samples to determine multi-residual pesticides, detecting the presence of DDT in 10% of the analyzed soils. The graph shows that the active matter detected is mainly the degradation product DDE, 72% of the sample, as this metabolite is generated by aerobic biodegradation, while DDE, 5% of the sample, is produced by anaerobic degradation. The presence of DDT is due to soils or highly contaminated, and it has not yet been completely degraded. In phytosoil, the analysis of fruit and vegetables, we have also detected the presence of organochlorine compound in some samples, mainly in plants that have a high capacity to assimilate these pesticides, such as melons, watermelons, or cucumbers. Next, please. In relation, uh, in relation to the use of plant protection products in phytosoil, we have three main activities: determination of the pesticide concentration in the plant protection product, degradation studies of pesticide in plant in collaboration with companies in the sector, and stability study of plant protection product or commercial fertilizer. The objective of a stability study is to simulate the normal long-term aging of a formulation by heating. It's preferable to obtain actual data from a product in warehouse, but the accelerated storage test provides a quick insight into the shelf life of a product for at least 2 years, as the warehouse test is not always satisfactory in countries with warm or temperate climates. Typically, the sample is placed in its commercial packaging for 14 days at 45 degrees, studying determine the concentration of an active substance before and after treatment at constant temperature. Next, please. As examples of this accelerated study carries- carried out in phytosoil, firstly, we had the case of the active material cyhaloderamide recently studying a sample of a commercial plant protection product with an acceptable 2-year stable result after evaluation of the sample with 46.3 method. In the second case, we have the application to physical and chemical properties in a fertilizer product in various parameters: humidity, pH, methods, or sulfuric acid, obtaining an adequate stabilization in the 2 years period. Thank you very much for your attention. Now, next speaker, Francisco Ferrer.
Okay. Thank you, Marco. Good night, good afternoon to everybody. And now that we have seen how we are applying in the field and the effectivity of the control by Agronomica, and my colleague Marco has talked about the substances that we are analyzing at Fitosoil, we are going to see how the pesticides are impacting in the food chain and the role of Fitosoil across the all this food chain in the different strategies for the control of the residues. So the most popular strategy is the farm to fork one. So there are several different names of farm to fork, farm to table, and different countries and associations that are applying this one. But all of them has the same in common. That is, they are focused in these three key areas: the food security, the sustainability, and of course the food safety. And these 3 points are very linked between them. And of course, the most related to the pesticides is the food safety, that we are going to put the focus in the next slides. And yeah, pesticides are in the focus of the strategy together with the fertilizers. And because of the purpose is to reduce the impact of these products in many different ways, like the amount, the type, the increase of the organic production, and all these kind of actions. Next slide, please. So according to this strategy, or the different strategy that we have for that, we should put the focus in the food chain. And in the food chain, we have different areas that we can find different risk during the use of the fertilizers and the pesticides. For example, when we are talking about farm and the growers that we have in field, there are different pests that they are finding, and the use of pesticides and contaminants is, the use of plant protection products is needed to fight against these diseases and pesticides. Also, the weather conditions can affect a lot in the use of the products that they need, and also the fertilizers that are needed for continue the crop growing. For the processing and packing, we are changing a bit the pesticides to the contaminants that we can have there because of the use of materials for the food to package the food or to keep the food stable in the storage before they are distributed. And in these last 3 points after the distribution, it's in the retailer and the final consumer, we have more or less the same topic, that is the microbiological aspects. We have also the pesticides and contaminants that are coming from before, but it's more related to the microbiological topics. Next slide, please. So how is Fitosoil involved in the food chain and the control of the different topics that we have seen? So our most important topic, as our name is telling, is the agri-food support that we are providing to the growers, to the farmers. So there we are helping the growers with these 3 different points. Well, more we have more, but it's the most important ones. That is coming from a good nutritional support evaluation to check that everything is going well with the plant and the crop. And then we have the inputs that are arriving to the crop, the external input like fertilizers and plant protection products, where we are doing the certification of these products and checking that everything is fine and according to the rules and the requirements of the regulation. And then we have the checking of pesticides and contaminants, all the analysis related to this that are performed in field before usually harvesting or after the harvesting during the processing of the food. After that, when we have collected the food and we are processing the food, we are the different contaminants that we have talked about. So we are performing the analysis of several of these contaminants in the industry and coming from the package, but also the pathogens analysis that are requested for the control of the food before it is served to the retailers or to the final customers. In the retailers, it's very important the risk assessment that they are performing. For different retailers are performing this kind of risk assessment, but also it's coming from the authorities, and they are doing the control before the product is arriving to the people, but they are also checking that is according to a good evaluation for the toxicological aspects. Next slide, please. So how we are evaluating this toxicity of the food, this toxicological aspect? Well, it's coming from the pesticide is coming from the field, from the first stage that we have seen in the food chain. So it's important to have a good and representative sampling to have a very good and complete toxicological evaluation, because in this case we have going to see or to check that everything is according to the rules of the application. Then we have of course, the evaluation of the residues and the substances according to the regulated to MRL that it has been applied, the maximum residual level that is enforced by law and with legal consequences if it's not attended. So this is the first one, and it's coming from toxicological parameters, but also from this efficacy and cumulative studies. And another point that is important to check in the evaluation of the toxicity is the dose of the acute reference dose, but also the ADI. These parameters are based only in the toxicology of the substance itself, and they are supporting the MRL to have the final MRL of the substance with a lot of other topics, but these parameters, specifically for the toxicology, are very important for the final evaluation and for these retailers and the consumer, as they are providing real information about the toxicology. And according to this, the MRLs and the RFD there are several substances of a high risk, and different associations and also these retailers are putting some kind of blacklist where they are placing all the substances that are very dangerous or they have a good high risk for the consumer. Next slide, please. Well, according to this evaluation, we are providing this kind of, we have this portal where we can see all the evaluation of the samples that we are receiving in the laboratory with all information for the customer, the date of the sampling, when the sample has arrived to the laboratory, all the information that we have, the pass of the laboratory, the pass of the sample across the laboratory, and also the final evaluation according to these different countries, to the presence of the substance in the official registration, to the evaluation of the RFD, and also the requirements of the different supermarkets. So next slide. Well, we have seen the evaluation and in the food chain and the impact of the pesticide, but we can put a small focus in the natural, in the organic production. And according to this organic production, we can check first of all that there are different natural substances and, of course, chemical ones that have been produced by the men. And in this case, we have several issues from the past, and probably we will have more in the future. That we have seen the Karanji matrine from a natural or plant-based origin. Then we have the chlorates or phosphonates with different origins from natural to a chemical one, and the quaternary ammonium salts that are all of them chemical products. They were different in different moment of the in different years they were a problem, and they were different causing different problems according to the stage that they were founding. And we saw then that it's not the topic is not that if the substance is natural or chemical. It's more about a good toxicological evaluation of the substance to check that this substance coming from a plant or coming from synthesis in a laboratory are having a good toxicological profile to be used in field. So next slide, please. Well, pesticides in organic production are regulated by different laws according to the country. For example, in the European Union, we have this regulation, the 848 of 2018. And then we have a specific regulation applying for the pesticide that can be used in the organic production. And this is different. In some moments or some substances are common in different countries, but we have seen differences of substances that can be applied in one country but not in another one. So not every product, not every usage. For example, if you have a tree for insects, you have a trap to kill insects. It's a different. You can use a substance, but you cannot use the substance in the field itself, for example. So we have different requirements, but also we can see that there are different strategies like the zero residues one or the baby food regulations that are applying with different levels for the substances with different MRLs, sometimes more restricted than the organic production. So it's different ways to keep the safety for the consumer. Next slide, please. And here we have two cases studies that we have in the past for substances in organic production, but also in the conventional one. In these two cases, we have the bromides for one side that was but a very long time ago problem with the methyl bromide has their own limit, and then for the bromides they establish a common MRL but all of them are linked. So how we are knowing that the bromides that have a natural occurrence in soils are coming from a methyl bromide application, or they are in the field. So in this case, for example, in BNN, determine an evaluation that we are checking the bromide cross the chloride ratio, and then you can see if it's a problem that is coming from, for example, from proximity to the sea, as we have seen in these pictures, and then you have a higher impact, or then you are having this bromide because of an application if you have a higher ratio. And the other case was the phosphonates, where we have this case of the phosphatyl aluminium that is um, providing or giving phosphonates after the application is um, decomposing these substances. So, but there are many other origins for the phosphonates, natural origins, and coming from the soil for application of fertilizers, and all these phosphonates are there after many years the application has been done. So we are continuing watching these phosphonates even in organic production, um, after, many years after the application. So the certification bodies have decided different strategies to check that the use of phosphatyl aluminum has been avoided, and these phosphonates are natural, from a natural origin, but it's still in some controversy to establish a good level that is coming from natural or from an application. Next slide, please. Yeah, and this is the last one, and it's just to show that we are really specialized in the organic production. We have been growing and growing in this side, and growing with the official control for the organic production with many different regions in Spain, but also working with different regions in or different associations in Europe, and getting the certification from different associations like PNN. So we have this accreditation program specific for the organic production, and we are doing this verification from the first stages in the fertilizers and for the biopesticides, as Marco was talking about the levels of the substances in them, and also to check that there are no residues, illegal residues, but also in all the stages related to the soils and the accumulation of substances there, or the control parameters that have been established in the European or other countries' regulation. So I think that's all from my side, and I'm returning to Dana.
All right. Yeah. Thanks, Francisco.
Thank you.
So, following our speaker's presentation, we'll now open the floor for a Q&A session. But before that, we received a few questions during the registration process. So, let me read the first question. How are regenerative agriculture practices specifically tailored and implemented within the tea sector to reverse soil degradation, foster soil health, and enhance ecosystem sustainability, resilience, and productivity? I think for this first question, Patricia, can you answer on this, please?
Yes, I can answer, Dana. Regenerative agriculture is a farming system that aims to improve soil health, increase biodiversity, capture carbon, and promote sustainable agriculture practices. In tea production, this may include intercropping techniques with plants that help fix nitrogen, use of organic acids, mulching to protect the soil and promote the diversity of plants, and beneficial microorganisms. This practice not only improve the quality of the tea, but also promote the health of the agricultural ecosystem as a whole. Integrating trees into the plantations can provide shade, improve soil fertility, and support biodiversity. Recycling organic waste into compost can enrich the soil with essential nutrients and improve its structure, promoting healthier tea plants. Implementing water saving techniques such as drip irrigation and rainwater harvesting can reduce water usage and minimize runoff. Encouraging natural predators using threat crops and employing biological control methods can help manage pests without relying on synthetic pesticides. In Brazil, we can give an example in the cultivation of erva mate, a biological control is used with the fungus Beauveria bassania in order to control the herba mate borer, one of the main pests of herbs here for us. With the implementation of biological products, there is a reduction in implementation and the application of chemical products, resulting in soil health.
All right. So thank you very much, Patricia. For the second question, how is it possible that a pesticide coming from a vegetable oil cannot be considered like suitable for organic production? So I think it's either Francisco or Marco can answer on this, please.
Yeah, Marco, you want to or
I prefer that you answer the, the question.
well, as I was talking about the organic, and I think that it's related to this part of the natural chemical compounds that can be used in the as pesticide. So yes, we have seen there are different pesticides coming from different vegetables, oils, plant-based origin. So uh, yeah, if we don't know the toxicology of the substance, is very it's very difficult to check if we can have this substance applied in the field. So it's important to check before, not only that is coming from an oil or a vegetable oil like we have in the past with carangin, and was or the matrine, that they were coming from natural origins, and they were at the beginning thought that they can be used because they were coming from a tree or from a plant, and as we are talking about an organic origin, they can be used in the field, but it's not that's done in only in that way. You need to check that in the regulation this substance had been included, and as we have in the European one, and if this substance is included because they have been applied in different protocols, then you can use it. But if not, it can be considered as not safe for the consumer, and then it has to be banned for the or use on organic production or even in conventional one.
All right. So thanks, Francisco. For the third question, have complementary tests been presented between the agronomical laboratory and the Fitosoil laboratory? So in the case of Brazil, we have seen more registration of chemical products for pest control in large crops such as soya and maize. Are they the same residue analysis test carried out on soil and food? So I think for this question, it would be Caroline.
Okay, so yes, this kind of tests are complementary between Fitosoil and Agronomica, and they are part of the same path that goes until the first tests from toxicity uh, uh, for environmental, human, and animals until food residues. And here in Agronomica, we test the effectiveness of these products, but we have a lot of tests that can be made and that must be made prior to this. Here in Brazil, we don't at Agronomica we don't do these tests, but we have other labs that can make the same analysis like Fitosoil.
All right. So thanks for that, Caroline. And then for the last one, how many years that does it take on average for a new chemical and biological product to be released for registration in Brazil, considering all the tests that need to be carried out. So for the last question, Patricia, can you help us answer on this, please? Patricia?
Hello, I'm sorry,
Yeah.
I didn't see
All
my
right.
microphone.
All
Yes.
right. Sure.
So
Go
now
ahead.
here in Brazil, the time it takes to register a new chemical product, considering all the tests that needed to be carried out, it is between 8 and 10 years. With regard to the biological products, we have seen a reduction in time. It's around 3 to 5 years.
Yeah. All right. Yeah. Thanks for that, Patricia. And now we go if, we'll check if we have received questions from our chat box or Q&A section. Patricia,
Yes, we
can
have
you
more
help us?
questions.
Yeah,
Yes,
sure.
yes. Then we have more questions. Can I read the questions here?
Yes, yes,
Yeah.
yes, please.
Okay. This first question. We have more four questions. Here was a widespread of the blackhead smart disease in maize that affected the majority farms in Kenya last season. Could this disease be associated with soil, farm inputs, or the phytosanitary practices in seeds used? And does it have any effects on the last consumer, whether humans or animals? I think I can answer this question, Dana.
All right.
Um, the causal agent of maize smut, how we call, also known as head smut or boil smut, primarily survives in soil and plant debris. The fungus overwinters in the soil as a teleospores, which are thick-walled resting spores. These teleospores can remain dormant in the soil for several years, waiting for favorable conditions to germinate and infect new maize plants. On managing of fungi effectively, farmers can employ cultural practices such as crop rotation, the removal of crop residues, and sanitation to reduce the inoculum present in the soil. Using disease-resistant maize varieties and avoiding planting susceptible maize cultivars in areas with a history of smut can also help minimize the risk of infection. Additionally, maintaining good soil drainage and avoiding excessive soil moisture can create less favorable conditions for the survival and spread of the fungus. In Brazil, we can say it has been estimated that every 1% increase in the incidence of head smut results in 100 kilos per hectare lost yield. The causal agent of maize smut does not typically pose direct health risks for humans or animals through consumption of infected maize. However, the presence of maize smut can lead to significant economic losses for farmers due to reduced crop yield and quality. In summarize, while maize smut primarily affects agriculture productivity and economic outcomes, it underscores the importance of implementing effective disease management strategies to minimize its impacts on food production and livelihoods. These strategies can include crop rotation, use of disease resistance, maize varieties, proper sanitization practices, and integrated pest management approach. We have another question, Dana.
Yep,
Uh,
sure.
I think Caroline can answer this for us. Kindly specify the units used in goals and populations.
Okay, I don't know if you remember, but I showed a picture about the galls, and the galls are abnormal growth of the plants, and it's induced by a foreign organism like a pathogen or like the nematode in that example, and it causes hypertrophy or hyperplasia of the plant cells, in this case in the roots. So to quantify these galls, we can count the number of galls present in the root. We can record the number of galls per plant. It's usually this way. And the population density is given by quantifying the population, the number of individuals, the number of microscopic worms, the number of nematodes in the soil. And we typically use the number of nematodes per unit by volume or weight of soil. So we have a nematode per cubic centimeter or per grams of soil. I don't know if it's more clear now.
So we just have one more question, Donna. I think
All
maybe
right.
Francisco and Carolina can answer these. Is it possible to regulate and come up with one or two cereals fumigants that, if used, the threshold will be within UA standards rather than allowing many players to retail their fumigants?
Do you
I
want to
don't know if
answer first, Francisco? In my view, like a phytopathologist, I can say that we have a problem if we just have one or two pesticides for use, because we have different cultures, we have different pathogens, we have different pests, different soil types, different climate conditions. So the same pesticide is not going to function in all this situation. And in another problem is in the terms of possibility of the pathogen develops resistance for this pesticide. So this variability of pesticides is very important, because we use to rotate different molecules in the management of disease or insects, pests in general. And it's very important to maintain this variability, because if you use just some few molecules, the risk of resistance from the part of the pathogens would be very high. And uh, we have a lot of problems. For example, here in Brazil, we have resistance for that fungus that I cited before, Phacopsora pachyrhizae, that causes soybean rust. So this variation and this variability is very important for management. I don't know if Francisco
Yeah,
wants to
I
complement.
I agree totally with you, Caroline, and it's part of the. I think that is part of the topics that have been worked by the retailers and also by the authorities. That is not to put the focus in how many substances are you using for the crop or to keep the crop safe. Is just to use the one that are needed, not only more and not only less. So it's good to have a different kind of products, different kind of substances, and to let the rotation of these products, because it's not, if we are using always the same one, we are going to have this resistance. And also there are different combination of weather possibilities, the pest itself, the kind of soil, the kind of plant that can be impacted by the use of the pesticide. And maybe this fumigant is not good in one place, and you need to have different possibilities to choose the one that is helping you to fight this pest. Yeah.
All right. So thanks, Caroline and Francisco. So Patricia, do we still have more questions?
No, we don't have more questions, Dana.
All right. So I guess we don't have any more questions from the participants. So as we near the conclusion of our program, we'll be sending an email in the next coming days, which includes a survey form and a recording of this webinar. And additionally, for more news and updates about Catecna, we will also be providing a link to our subscription newsletter, and you may also reach out to us using the contact information flashed on your screens. So we hope you find this webinar beneficial, and a big thank you to our speakers, Patricia, Caroline, Francisco, and Marco for sharing their expertise, and to all of you who joined us today. So have a great day, everyone, and see you again in our next webinar. So thank you very much. Bye,
Thank you.
everyone.
Thank you.
Thank you.
Thank you.
Bye
Thank
Thank
bye.
you.
you.
Bye.
Bye.